He was born in Russia in 1834. Hard work as a youth opened up the college doors. He always tried to be the best that he could be, and chose to make his mark in chemistry. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. He wondered if nature really had a master plan, if the elements had a pattern that one could understand. So he bought a bunch of cards, and on each one wrote the name of an element and its weight, and then he played the game. He put them all in order by their atomic weights. He used their chemical properties to differentiate. Groups began to form, and despite some question marks, he managed to produce a simple periodic chart. Who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. At first, in 1869, the chart was not a hit, but that young Russian chemist was not the kind to quit. He revised atomic weights and staked his whole career, predicting that several new elements would appear. Well, a few years passed, and sure enough they came. Gallium, scandium, germanium were their names. Chemists everywhere were impressed with what they saw. There really must be something to this periodic law. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. So they call him the father of the periodic table, and his work gave rise to another kind of label. It's the name for element number 101. In honor of this man, they call it Mendeleevium. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev.
In 1869, Dmitri Mendeleev could see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat. The elements we know about, they number 114. Some in quantities so small that they've never been seen. Most are common elements that are far and wide dispersed, but all of them together make up all the universe. Elements in group 1 are called the alkalis. They explode in water and are of very tiny size. They love to lose electrons when they form a bond. Of these reactive atoms, I can say I'm rather fond. Group 2 elements are often called alkaline earth. Calcium's been building bones since well before your birth. They form nice +2 ions and are generally quite fun, though they're not quite as reactive as the metals in group 1. Since 1869, every one of us could see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat. Metals in groups 3 through 12 transition elements. Some of them are lightweight and others really dense. Things they have in common, they form charges 2 or more. And some form colored compounds, which is something we adore. If you want an element, just tell me once again. If it's in group 17, you've got a halogen. Nonmetals so corrosive, they're not found in their pure state. They can gain electrons like they're going out of date. Got one for you in Group 18, it's known as noble gas. If you're looking for an element that just sits there on its... If you wonder why and haven't figured it out yet, their valence configuration is a big stable octet. So now it should be obvious that everyone should see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form